And we are live. How are you doing today, Angela?
I am on top of the world.
I know
Thank
you
you
are.
for asking. I'm on top of the
Uh,
world. I'm fine. Thank you.
cool, cool. Excellent, excellent. But yeah, here we are again. I'm glad you made it in. I know you're coming in hot from all your activities, a day full of tech and mingling.
Yes,
And yeah, and we get to continue the party, continue the hype
I
because
know.
we're talking about programming AWS Lambda on from cover to code.
Yes, I am just coming home from DevOps Days Atlanta. It was a 2-day DevOps conference in Atlanta Midtown. It was absolutely amazing. We had who was one of the speakers was our friend of the show, Angie Jones.
Yeah,
She did a phenomenal talk on MCP that, when polled, that was the highlight of day one. So
yeah,
that was
had to be.
fantastic. I saw a talk today on what we're going to be discussing today, chapter
Ah,
6, with uh, logging and
yep,
testing. I'm sorry, and then chapter 7, monitoring. There
yep.
was a whole talk on it, and so it's fresh for me. And I'm on cloud nine. I got John
Excellent.
Willis, to the the gentleman who was one of the writers on DevOps Handbook.
Right. Throw
He's
back to season one.
Yep, season one of From Cover to Code. He signed my little book, and he gave me another copy of a copy of his most recent book. Like, because
Wow.
we're about that book life. But
I
anyway,
know. I
I'm
know.
I'm so happy to be back and talking about chapter 6 and chapter 7. Let's get into it.
Indeed. Indeed. Yeah. Chapter six, testing. I mean, we can jump right in
Yes.
to the like. I thought it was kind of interesting that he led with what he called the test pyramid, referencing and this is from the book here. I'm reading directly. The 2009 book Succeeding with Agile by Mike Cohn. I'm assuming that's the pronunciation, where they talked about this test pyramid and the types of tests that we can bring into our software development. And I'm a visual explainer, so I had to bring the test pyramid into the pod. So if
Good.
you're
Good.
watching us live or watching the replay, we're going to be using this diagram from the book to kind of lead the discussion here. But if you're listening, check out the show notes, maybe for links to the slides, or check out the video and you can see the pyramid there. But yeah, starting with tests, they started out with unit tests, and these are tests that are fast. They should be run often because they check like the base functionality of functions and functionality of the code, and it shouldn't have any external dependencies, which in my
True.
opinion is kind of what allows it to run quickly. um, Unit tests are my favorite. I like to build unit tests
The
into
quick
my
hits.
projects.
The
Yeah,
quick hits.
exactly, because they give me confidence to know that I didn't break anything. Basically, if I
Confidence
have,
boosters.
yeah, exactly, because if I start with some code and then I make a little change and then I deploy that without testing it, then I'm like, oh, did I really do what I, number one, thought I was going to do, and number two, did I break anything else? So if I make a change, almost always before I commit, I'm running some little test script to say, hey,
Awesome.
yeah, check out this code. Just double check, make sure everything's good before I commit it to the repo.
And in this
Um,
diagram, it tells you what we just said. Quick tests. You run as many of them and as often that you
yeah,
need. There should be no dependencies, so you need them to run very quickly. You have as many tests as you need to confirm that your code is working. You catch bugs early in the development process when you do a lot of unit testing. And yeah, there. It sounds like you're a fan of unit testing.
yeah, indeed. My I guess approach is one at the very least one unit test per function.
Or function or method.
Yeah,
That's right.
yeah. And then they also talked about I don't know if it was in here, they talked about it, but the happy path, like you always test for the way that it works. But if you like are really about that test life, you're going to maybe add 2 tests per function, and you're going to test for the failure scenario
Yes.
where somebody gave you bad parameters, like how does your function respond? It should have some sort of failure response. So you want to test for that failure response as well.
So there was
well,
a talk today at DevOps Days. Develop without fear using automated tests. And one of the things that he also mentioned was kind of what you just said. Like, you want to test for those worst case scenarios. You want to find those bugs. You want to dig into those issues. And testing shouldn't be oh man. No, you should want to test your code, because that gives you the confidence of knowing you're not going to push bad code out. You know, you've done your due diligence. You want to catch those issues quicker in the development process as possible. So unit tests are definitely the bee's knees, and super important.
Yeah, and there's even and I don't think they touched on it in the book, but test-driven development, where you develop the tests first, and then write the code so that the tests pass. I mean, that's like flipping testing on its head. Yeah, and then just running it from that way. But
they didn't mention that. You're right. They didn't mention.
Yeah, I'm surprised they didn't. I don't know. Yeah, they use their own approach. I mean, I'm not going to hate on it, but yeah, test-driven development, that's a big thing too. But the next level up in the pyramid is functional testing. These should also be quick tests, but they should bring in the concept of a dependency, but use mocks to kind of stub them out. So you don't actually have an actual database. If you're, say, developing a function that talks to a database, you have some little software database that your function can connect to virtually, and do whatever it needs to do there. And the testing environment sort of sees both sides of it. It sees the function, it sees this mock database, and then it could sort of monitor the interaction and make sure everything's good there. And that's part of the test as well.
Yes. So it says here that it shouldn't, unit tests shouldn't have external dependencies, but functional tests should also not have the real external dependencies. You create something called a stub. You use one of those to mock up or to mimic basically what that connecting and that test would look like. Functional tests, sometimes called integration testing. If that's the language you use, in tech, there's multiple names for one thing. So if you're used to using integration tests, this is basically where it is on the pyramid. And you can check that a small group of components are working together to deliver, say, a specific feature. They also run quickly. You're testing various layers: database layer, API layer, the business logic, things like that. And this is another thing where you're testing things before it goes too far. They address major code paths, as they call it, for a particular component. And you find out where things don't intersect or interact properly. So that's what integration testing, where things are integrated together.
Yeah, and in particular, like for the example that we're going to use for the demos that we got coming up, it's really, I'm carrying on the code from chapter 5, where, and I can't remember if it was chapter 4, but where we talked about the weather data API. So if you are just catching up with us on this episode, go back an episode or two, and you'll find the application that we're working with. But it basically has 2 functions in there. One function writes to a DynamoDB table. One function reads from the DynamoDB table. So the unit test would test each one of those functions individually. Like writer function, can you write? And do you write the correct data? Reader function, can you read, and are you reading the correct data? And then this functional test says, okay, I'm going to bring both of those functions together, and at the same time, or not at the same time, but you know what I mean, in the same test pass, we're going to write and we're going to read to make sure that everybody's working together exactly as they should. And that's what you're like you're referring to that integration test, we're integrating these two functions into the application,
Yes.
and running them at the same time. But we don't really have that database. It's kind of a fake database, but at the same time, we're testing out the entire structure, the entire architecture of the application, which leads us to the top of the pyramid.
The money shot right here.
Exactly. You gotta have your end-to-end tests.
Woo.
Yeah, and this is where you're testing the entire application with its dependencies.
That's right.
In a manner that's similar to your production environment. And the authors did say, like, these tests, you don't expect them to run quickly because you have to stand up your infrastructure. Maybe you have to compile the code into a package and actually deploy it, that type of thing. And then you run your tests, because you're actually using the stuff where the test is going to run. And if the tests pass, you can tear down your infrastructure. Or if they fail, maybe you want to leave that infrastructure in place so you can debug and investigate and that type of stuff. So end-to-end tests take longer. Maybe they aren't done as frequently, but they should still be done often.
Agreed.
You know what I mean?
That's what he mentioned in the book. They said it's the most expensive app to run, meaning it takes the most time, it tests the most components, and you can only end-to-end test on those important scenarios. You can't possibly on an end-to-end test to do everything, every use case, every user story or whatever. That's hard to do. So you find the ones that have the most impact, the most important scenarios, going through all the layers of the application, and validate it says in the book, to validate critical user journeys, how that workflow goes through your application. And so these are the money shot. Well, end to end is definitely the money shot, but the pyramid, you work your way up to the top of the pyramid.
Yeah. And I'm glad you brought the user story idea to mind, because I can imagine, I'm using a Chrome browser right now, and I can imagine all the different teams and all the different software they're developing, all the different functions that go into the Chrome browser. So maybe these teams, they have their own unit tests, and maybe they get together with other teams and do these functional tests. But then, you can't do end-to-end tests on Chrome for every single manner that it could be used as a individual, or maybe even as a small team. But like you said, you could say, well, our function is the bookmark function.
Right.
So what we're going to do, we're going to do an end-to-end test that proves that somebody can start Chrome, they can create a bookmark, they can edit a bookmark, and they can delete the bookmark, and then our end-to-end, that is our end-to-end test. But there may be another, like the extensions team. Okay, now you have to do your own end-to-end test, and let somebody else, down the road, bring all these end-to-end tests together and determine how they're going to be run, when they're going to be run, and so on and so forth. So, large scale projects take a lot of testing. So I can only imagine, what that end-to-end testing looks like.
And there are some organizations who, they test. If you're really big, you might have a whole team who does testing against your application or service. Excuse me. So your mileage may vary. It might be your team. It might be a team adjacent, but you should always write your code with testing in mind, with test-driven development. So again, it didn't touch on it in this chapter, but know that even in the book, the code that it provided had to be refactored because it was put together in such a way that didn't make it easy for testing. So this is a great segue into the next section where it talks about refactoring your code for testing. And in the book, it focuses on chapter the data pipeline code from chapter 5. We didn't talk about that one, but you can download that code and take a look at it, and it shows you that you're going to write tests to do certain things, and the code is imperfect in its original state, but it shows you, there are 4 methods in this class. You want to pick them apart and write them in such a way that they can be individually tested. So
Mhm.
I don't think that matters on the language you're using. It's just that in this example, they talked about how they would refactor for those events. So
Yeah.
yeah.
Yeah, because they were flying through the code earlier and just trying to get things work, because you can't overwhelm people with
Not
hello world. But wait, before you print hello world, let's develop a test to make sure that your function printed hello world. It's just like, okay, let's print it and we'll move on. And then, down the road, don't forget, we're going to update this code to actually run some tests. And I also think that refactoring for testing is a true to life venture for people who come into new teams or new companies or new projects, because
yes.
you jump into that seat. You're like, hey guys, I'm here. What's up? Let's get cracking. And they're like, well, the first thing that we're gonna do
First
is
of all,
yeah, we don't have any tests. Well, why don't you have any tests? Well, look at our code. So
ta-da!
exactly, get ready to refactor if you're coming into a new
That's
team,
a
even if
great
it's
learning
on your
opportunity.
own sort of regard. But I would say first, ask the questions. Don't just make changes just because, but say, hey, where are the unit tests? Where are the functional tests? Oh, we don't have any. Well, okay, I'll start there. Let's make unit tests for all these functions, and then then I'll start thinking about making some feature changes or something like that.
Awesome.
Yeah,
So again,
refactoring is
this book is
important.
all Java all the time.
Yeah,
It's a whole section on adding constructors
yeah,
and
yeah.
things like that. We're as they say, we're not getting into all that.
No,
But
yeah.
what we will talk about is your example.
Yes, before I get into my
Oh,
demo,
yes.
which is package is simmering on the stove, it's ready to go,
I love it.
piping hot. There are a couple other points that I did want to reflect on that the authors called out. Local cloud, quote unquote, testing versus real cloud testing. So
Okay.
we talked about with functional testing where you stub out some of those dependencies.
Yes.
And for this code in particular, the author's code and the code that I'm going to demo, it uses DynamoDB, which is a cloud service running in AWS. There are software packages that I can run locally, or anybody can run locally, that simulate interaction with DynamoDB, right? So we could use that as a dependency, maybe even for our end-to-end tests. But the problem with that is it doesn't really, or it may not represent the way that the code will run on the real stuff. And I think the example that they gave was memory utilization. So like you could program configure your Lambda function to use less or more memory.
Mhm.
And that may not be reflected if you're using this sort of
This local
simulator,
testing
this
tool.
cloud simulator. Yeah. So say you give your function all this memory to use. Yeah, it works when you run it locally, but then when you run it in the cloud, maybe it doesn't work the way that you expected it to with the data that you're giving it. So in my preference, honestly, I prefer to just do it in the cloud as opposed to locally, because you're at least in my mind, I'm always wondering, okay, is the local system really giving me the real
The real
deal? Like,
accurate.
yeah, and if something breaks, then am I debugging my code or am I debugging the
Are,
simulator?
exactly. Are you troubleshooting the right thing?
Yeah,
So that layer of I don't want to call it abstraction, but it's not the real thing. You want to test in an environment that is close to the real
yeah,
environment that you can get, because then you get a not on my machine moment
yeah,
or opportunity. That's why people have different environments.
yes,
They develop in one, they test in another, they stage in another, they implement in another. They go because of this very thing. You want to get as close to your environment as possible.
yeah. And that was another point that they made that I totally agreed with, that all devs should have their own cloud account. Like, I mean, say it louder for the people in the back. It's like, have and in my opinion, have the production account that is hermetically sealed. Nothing's going into that account unless it's going in through some programmatic CI/CD. But all these staging and test and
Mhm.
QA accounts test accounts, which everybody should have their own to just sort of play around, Wild West, spin stuff up, do what you want. Maybe put some caps on it for spending so people aren't going crazy, you know, but give everybody their own account. Because I've worked on teams where we did have test environments, but they were always clashing for resources. Like if there's a database that people want to make changes in, run migrations or whatever, but I'm already like 20 commits ahead of somebody that's behind me testing something else out. And if I make these changes and we're using the same database, I'm going to break their stuff, you know? So, but if I have my own account where I'm doing my own thing, I got my own DB, then we're good. You know, I can make my changes, make sure everything's good, commit it to main, you know, and if you want to pull those changes into your branch, then you're good. You know, you got to catch up. Yeah. But otherwise, I'm not going to interrupt your development.
I wonder how popular that level that is, where everyone gets their own account versus if you have access, everybody has the same access to the same environment.
Mm-hmm.
I mean, apparently where you work, that is part and parcel, but I wonder how prevalent that is.
Yeah, I really think it depends on the size of the team, how much money you're willing to spend, and also, really, I think what it boils down to is how much governance you want to apply across your teams. Because if you have, and it's easy to do in AWS with sub accounts, you can have one master account and create, or organizations, I think is what they call it. You can create as many different accounts within this organization as you want to, but then somebody has to manage them, you know? So it's like, do you really want to spend the time or assign somebody to manage these accounts so that everybody has their own test accounts? I'm down with it because I've worked I've worked with teams for each single application. There is a separate AWS account for tests. There's a separate AWS account for staging, and there's a separate AWS account for production. It's Wild West in testing. In staging, things are a little bit more controlled, you know, CI/CD pushes, but you can get in manually and touch stuff. But in production, nothing's going into that production account unless it's pushed in by CI/CD and it's approved by the people who need to approve the changes. So I was cool with that.
Board or whatever, the change board. We talked about that in the last book.
Yeah. And it doesn't have to be like, oh, you can only push changes once a week, or we meet on Wednesday at 3, you know, that type of stuff. It could be automated and maybe somebody gets an alert and they just click OK and everything. So, but anyway, I don't want to spend too much time talking about all of that. Let's get to a demo of, and again, I always got to square my screen away, right, as I get set up for stuff. But let's,
because we love demos too.
Yeah, demos are great. And if you are watching live, I'm going to be showing some code, some of the test suites that I'm using. And if you are listening, you can find this code. And let me put this up on the screen. You can find this code in our GitHub repository, github.com/cover-to-code, season 2 programming AWS Lambda. And there's a folder in there, a directory in there called chapter 6 and 7 or something like that. That's where this code will be. So you can find it there if you want to follow along.
Sharing is caring.
It is indeed. And it's all open source. I mean, you know, and that's why I'm wearing my GitHub, my OctoCat shirt today. You know,
we could have been twinning. I thought about, actually I was going to wear the sweatshirt because I left out the house today to go to DevOps. You always have to take something with you. So I have a GitHub sweatshirt. I don't think I have my t-shirt anymore though.
Oh man. Okay. But yeah, the conference rooms, they get cold sometimes when you're in conferences and seminars and stuff. So yeah, you got to bring layers basically. Yeah. Okay. Getting into the code. So no Java here. It's all Python. But similar to some of the stuff that the authors spoke of as far as mocking things, the Python library unit test comes with some packages that allow you to mock services. So in this case, we're going to be mocking DynamoDB and the tables that we have there. And then, I have, this is the, each of these classes is a different set of tests, right? So when unit test runs these, it'll pick up these tests. And Yeah, so this is basically testing, creating a weather event class. This is very simple, and not too critical. But
Mhm.
then we have the event where we're actually writing stuff to the table. So this is testing our event function, which connects to the database and actually saves the data. So again, we're testing the successful event processing. And if we go down a little bit further, we're testing the invalid response.
Okay.
So like it put invalid in here for the temperature. And so when that data comes back, it's going to be like, no, this is not correct. And it's actually testing for this value of 400, the error coming back from the database or the function. The other function that was in our application is where we're querying the database. So we're actually reading data back. And similar tests, we're testing the successful query. And then we're also testing, there's a limit with reading from DynamoDB. So it tests with this particular limit.
Okay.
And then we also test a query error, which I guess in this case, it would be a 500 error reading from the database. So we're testing the happy path, we're testing the sad path, and we're testing some of these edge cases where limits or other stuff might be in
Got
place.
it.
Yeah.
You wrote very
And,
good tests.
well, thank you very much.
I see this as your jam, and you've given this a lot of thought.
Yeah, hey, I try to do my best with, if I have a function or a code or something, like give me, like I said, at least one, if not two tests per function. So threw some in there extra as well.
Awesome.
So, and this covers my unit and functional testing.
Okay.
So at least I'm gonna claim functional testing. I mean, somebody can, if you got problems with like, hey, no, that's not a true functional test, let me know in the comments or something and we could talk about it.
Love that. Love that.
I did put some effort into the end-to-end test. So, and this is all, it's a bash script. I went back to basics for scripting. No Python here, but what I like about this is it's totally automated. We're going to see these tests run here in a minute, but I just wanted to break down the code a little bit.
Fantastic.
So it's got a lot of good logging, and I guess we'll talk about logging in a little bit, but it does everything. It installs requirements for testing the application, for building the application. It does the SAM build, it does the SAM deploy. After the code is deployed, then it actually gets the endpoint, like the API gateway endpoint, so that we can write data to this particular environment. Now, I've already got one of these things deployed, and I don't want to do tests against my production, quote unquote, environment. So
Gotcha.
this is a totally separate environment. So I have to dynamically get the endpoint for it. So this command here gets it uses CloudFormation to get the output, which has the API endpoint. I set that as an environment variable so that the functions can pick it up. And then I have some functions that actually push data into the database using the endpoint. And then I've got another function that reads it back. So both of these functions are using the same data source. So I know what I'm writing in, so I know what I should be getting back. And that way I can test to make sure that everything worked properly.
All right. So we're going to see. Let's see what we got here. This is unit test first, correct?
Yes. So I'm also a big fan of Makefile. So really, I could just run make test, and this is going to run my unit and quote unquote functional tests. So you see they run pretty quickly.
Yeah.
Less than a second, and I got 6 tests run.
That's a good unit test. Quick and effective.
So I'm like, while I was pulling this code together, I'm running this unit test with every commit. Just about, I'm like, hey, did I break anything? Make test and then like git commit. Make test, git commit. Because it's so fast, it doesn't even slow me down. From checking in my code, from making changes or whatever the case is. So that is my unit and functional test. So we're already 2/3 of the way up.
All right. All right. Now we're going for the money shot here.
We're going to the top, to the tippy top of the pyramid is the end-to-end test. And of course I have a make target for that.
Let's do it.
I'm going to start it because it's going to take a little bit longer to run.
Okay.
It's going to install all the requirements, which are already there. It's going to build the thing, and you see there the build succeeded
from the SAM build in there.
Yep. So now it's deploying it. You just saw it uploaded the template, and now it's running CloudFormation. and CloudFormation says, hey, I'm going to add all of these resources. And so then it starts to deploy these things. You can see the DynamoDB table is starting to be deployed. That takes a second to run. DynamoDB table is now complete.
Next is...
So now are the functions, roles that the functions will assume when they run. And once that role is in place, you can create the functions. And I believe once the functions are in place, you can create the API gateway and everything will be good to go. So yeah, there's the role and there's the query Lambda, event Lambda.
Okay.
In progress. There's the API gateway.
This is absolutely testing the entire process from end to end.
Yeah,
from,
so
from building to infrastructure to security to deployment, the whole shebang. And now this testing is, you said you are testing both writing to the database and reading back from the database.
Yeah, so I'll scroll back a little bit. So yeah, after everything got deployed, I got my endpoints. And once everything was ready, then I could start testing against those endpoints. So I've got 49 data points that I'm writing to. So all 49 of these should go through. They all get written down. I get 49 successes, 0 failures. And then I could start verifying these. I can read back. So the way that this function works, you write in one data point at a time, but you get them all back with one read. So once I get them back with one read, I can start verifying each one. So verify each of those locations, and then they all matched. And so the cool thing here is that on this line here, the script checks to see if all the tests pass. If there were no errors anywhere with either building, deploying, writing, or reading the data back, then and all the data read back was correct, then all the tests would have passed in this end-to-end test.
And that's
so we don't need. Yeah, exactly. Then we don't need to keep everything around. So it says, well, test pass, I'm going to delete all of this stuff that I deployed, and it cleans everything up. It
Fantastic.
Deletes it again. So yes, really, really like end-to-end testing in that manner. SAM makes it pretty easily because it gives you a lot of good handles for building and deploying. CloudFormation outputs was really kind of cool to use to get the interface to the application. And then, my other tests were Python, the writing and reading. So there was some Python in there, I guess. But yeah, that's my unit, functional, and end-to-end tests in probably less than 5 minutes.
You got to love it. So we're talking about, in chapter 6, we're talking about testing. Chapter 7 is talking about monitoring and logging. And we're not going to get into that today because you have a sample for
I got some logs to show. Yeah.
Well, of course, because logs have been generated.
Yes.
Spinning up this infrastructure and deploying this. So, I think we can extend this a little bit and dive into.
We're almost over time. Wow, I didn't even notice it. Okay, I'll be real quick.
Time flies when you're having fun.
It really does, because like I said, I yapped about testing so much that I totally forgot or was not aware that.
I think we can all feel your passion for testing.
Yeah, no doubt. Okay, so
CloudWatch, here we come.
Yeah, right. Okay, we're going to get the CloudWatch in just a minute. So I've got the same scripts that I use for my end-to-end tests. I have them configured because all you do is you pass to them the API that you want them to interact with. So I've got scripts create weather data and verify weather data that will read and write. And in this particular case, I have them configured to use the production endpoint. So this output is going to look very similar to the end-to-end test, with the exception that it is writing to the production environment instead of the test environment. So I'm going to let that run really quickly. It probably takes less than 10 or 15 seconds to go through all of that. Okay. And then again, the tests or the verification, it just pulls everything back in one read, does its thing, and then it's good to go. The benefit of that is it brings me, or it basically writes to log groups. And within the log groups, well, I should say there's a log group for each function. So each Lambda environment is going to have its own log groups. And within the log groups are log streams, which kind of collect all of the output that the function has generated into one particular place.
Mhm.
And a couple caveats here, I'll be really brief, is with log groups, definitely if you're working with SAM or anything in AWS for that matter, create your own log groups and configure them so that you get expirations that you want, because otherwise they will never expire. I'm looking, some other functions that I've deployed that, and this one's going to go away here again in a little bit, this in the end test, but like this function right here, Zappa test, I was messing around with another serverless deployment application called Zappa 3 years ago, and those logs are still there because they will never expire. Benefit with SAM, if you configure your own log groups, then when you tear down the infrastructure, then those log groups will go away.
Okay.
Yeah, but while they're running, you can still configure the retention. Otherwise, you're going to be charged for this data that's just sitting around doing nothing, So I'm going to clean some of this up. A lot of these functions I haven't deployed for quite some time, or haven't even used them, whatever. So I need to get rid of that stuff.
But let's get down into the log stream.
Yes, indeed. So you get to the log groups and you can find your log streams, and they're sort of collected together by time. These are some that I've ran earlier today, and this is the one that I ran most recently. And there are the messages that are, I guess to kind of break it down a little bit, by default, Lambda is going to give you the start message to let you know that a request to your function has started. And then you also get this end message for free that tell you this is where your request has ended. And anything in between these start and ends is output from your function. So my function is only printing one thing at the moment. Information wise, if I had debug turned on, you'd get more stuff. If I had errors, then you would see those errors. But right now it's just info. So for every execution, you're going to get something like this that says, hey, I successfully wrote to this location. I also have configured a service. This is for stuff that I didn't get to as far as like tracing and metrics.
Okay.
You can use service names to kind of collate data together and custom metrics. And you can use X-ray IDs for tracing inside some other tools that CloudWatch exposes. But I didn't get to that in this particular week. So I'll leave that as an exercise for the listener, the reader, the viewer, the watcher. One thing I did learn from the authors in this particular case for logging is that the preference is to use JSON logs for processing in other systems. And also because if you put all your stuff into one JSON object and then print that object, then you'll get it on a single line. Otherwise, your output's going to be like if I had one output line for the level, one put outline for the location, the message, the timestamp, so on, then they would be in these different little handlebar things, these twisties. They would be on different lines. So it'd be hard to kind of catch them, together.
Okay.
And the last thing that you get is a report that lets you know how long the function ran, how much they're going to charge you for this, the build duration, how much memory you used as well. So lots of good information with logging. Yeah. And the other caveat that the author said was watch out for how much you log though. Log what's important for you in your debugging, because otherwise you may end up with unexpected costs. I'll just leave it there.
And you don't need to log everything because everything is not germane to what you're doing. And again, everything that you write to CloudWatch goes into S3, it's going to cost you. So be mindful. Again, you mentioned something about the expiration of the logs. Be mindful of that as well. And those are two tenets in AWS. Like, don't just be spending money just to be spending money. Make sure
I know.
But it's easy to do. Like you have logs sitting around for
3 years.
Yeah. And when we started this, I had stuff sitting around. I'm like, okay, I can't remember when this got here. But then I saw the date, years. So clean up after yourself. Be very
Yeah.
diligent so you don't get these crazy AWS bills, or get them over a course of a few years. Like, we've done, we haven't noticed it, but yeah.
Yeah.
Don't waste your money. Make sure you clean up after
Yeah.
yourself.
Definitely.
Well, I think this was great. I think your example hit all of the marks
Yep.
as usual.
Thank you very
With
much.
Python. No shade to Java.
Yeah.
But it was just much more readable. It was much more approachable. And yeah. And again, this book is Java focused, so it kind of focuses on how you log
Yep.
in Java and things like that. So if you are a Java developer, this is definitely your Lambda Bible,
Yeah.
because it's talking to you specifically. And we're going to head on to our next chapter, which is what?
Yeah. Yes, indeed. Next up, we are talking about advanced AWS Lambda. Now, I haven't cracked the pages. I haven't gone beyond chapter 7 to
Mhm.
see what they're considering advanced. I mean,
Good
some of the
question.
logging stuff is pretty advanced when you get into tracing and custom metrics and that type of stuff. So I'm very interested to see what they consider, or what they have reserved for this chapter to be called advanced.
I'll give you a hint. It
Okay.
has something to do with error handling and scaling.
Ah, okay. I can see that. Yeah.
A little bit more advanced topics.
Cool. Yeah. Well, what you will see from my side is more of this weather data application. So
Yes.
prepare to be sick of seeing weather data, because if they come with something different, I'm just going to apply it to the same weather
Hello.
data app.
What they say, prepare to be sick of me. Yes.
Yeah.
He's preparing you for next. We're going to ride this weather data app, because the book switched and went to a pipeline application. So
Yeah.
Michael's going to be very consistent throughout the rest of the book, which is not much left.
Yeah.
So
Yeah. I think we got maybe a
2
couple more
chapters.
sessions on this book. Yeah. Yeah.
I think we have come to the end of the road.
Yeah.
As New Edition, or sorry,
Right.
not New Edition. That's
Boys to
it.
men.
That's it. Boys to Men say it. We're at
Yeah.
the end of the road, and
Yeah.
but this has been such a ride. But these last 2 chapters, 8 is advanced AWS Lambda, 9 advanced serverless architecture. So,
Nice.
and then there's a little conclusion chapter.
Yeah.
We're gonna put it up in a nice bow.
Yeah. So maybe this is a good point to say to the folks, if you're listening or if you're watching,
Yeah.
and you can think of something that you might want us to consider for
Mm,
season 3 of From Cover to
yep,
Code.
it's coming. It's
Yeah,
coming.
drop it in the comments, hit us up on the socials, let
Please
us
do.
know.
I
Yeah,
have
what
my
you
wish
think.
list.
Oh, yeah, you I know you got a list.
I got a wish list. Yes, I do.
Yeah. So I need to be pulling some stuff together myself. Yeah, to think about what what I want to get to next season.
Yeah. Well, this was fun as always. Thank you for
Yes,
being
indeed.
patient with me. Again, I was running in the house right before we got on this stream, and I'm glad I made it. I didn't want to miss this for anything, because
Yes, indeed. I'm glad you made it too.
I absolutely enjoy having these discussions week after week. So, and I
Yeah.
hope the people who are watching and listening enjoy it just as much as we do, because it's
Yeah.
really a gas. So,
Yeah.
thank you.
Good times, y'all.
Until next time.
We will see you soon.
See ya.